Hi, my name is Suzuki. I'm an assistant professor at the University of Calgary, Department of Computer Science. Today, I want to talk about augmented reality and robotics, a survey and taxonomy for AR-enhanced human-robot interaction and robotic interfaces. So this is a collaboration with Adnan and Karim, Tian, Hooman, Hedayati, and Nick Marquardt at University of Calgary, University of North Carolina at Chapel Hill, and University of College London. So this paper is about intersection between augmented reality and robotics, and we have surveyed 460 research papers about AR and robotics to understand how we can use AR or mixed reality to enhance human-robot interaction, but also robotic interfaces such as actuated tangible user interfaces and shape-changing interfaces. So with the recent advances in AR and mixed reality, there are a growing number of the research papers that investigate how we can use AR for human-robot interaction. But existing papers mostly focus on individual exploration. So in this paper, we try to synthesize this work into the different dimensions of the AR and robotics paper. So for our contribution, we have synthesized this paper into the 8 different dimensions, but we also summarize our paper into the interactive website so that you can, if you go to this website, you can actually see all of the research paper with interactively to dig into each research paper. So in this paper, we have analyzed the different dimensions of the AR robotics. So the first one is approaches to augmented reality in robotics. And the second, characteristic of augmented robots. And the third one is purposes and benefits of augmented reality. And the fourth one is the classification of the presented information. And fifth, we have design component and strategy for visual augmentation. And the sixth, we have interaction and interactive modalities. 7, we have application domains. And also we have evaluation strategies. So based on this finding analysis, we also discuss the future research opportunity and challenges to inform the research community for the future of AR and robotics research. Then my student Adnan and Karim will be talking about each dimension and taxonomy.
Hi, I'm Adnan, and I'll pick up where we left off. So in terms of approaches to augmented reality in robotics, we had on-body, on-environment, and on-robot. And that could be done whether augmenting the robot or we could be augmenting the surroundings. In terms of characteristics of augmented robots, we had multiple form factors. We had robotic arms, drones, mobile robots, vehicles, to name a few. In terms of its relationship, we had a 1-to-1, 1-to-m, n-to-1, and n-to-m. In terms of scale, we had starting from small all the way up to large. In terms of proximity, we had near proximity, anything in between, and then also far proximity. In terms of purposes and benefits of visual augmentation, we had facilitating programming, supporting real-time control, improving safety, communicating intent, and also increasing expressiveness. In terms of classification of presented information, we had internal information, external information, plan and activity, and also supplemental content. In terms of design components and strategies, we had 3, which is UI and widgets, which fell with menus, information panels, label and annotations, control and handles, and also monitors and displays. We also had spatial references and visualizations, and things that fell under there was points and locations, path and trajectories, areas and boundaries, and also other visualizations. And finally, we had embedded visualizations, which had anthropomorphic effects, virtual replicas and ghost effects, and also texture mapping effects. In terms of interactions, we had low to high, including only output, which is low, implicit, explicit and indirect, and also explicit and direct input. In terms of more interaction, we had tangible, we had touch, controller, gesture, gaze, voice, and also proximity. In terms of application domains, there are multiple, but we'll name a few. Industry was the most popular. We also had mobility and transportation, social interaction, and also medical and health. In terms of evaluation strategies, there was 3. One was demonstration, technical evaluation, and also user evaluation. In terms of discussions and findings, we found a lot of things, and here is a summary of what we found. And in terms of future opportunities and challenges, we've had 4 things we wanted to focus on. So the first one is making AR/HRI practical and ubiquitous, things like technological and practical challenges, and also deployment and evaluation in the wild. We also had AR/HRI for better decision making, including real-time embedded database for AR/HRI, and also explainable and explorable robotics. We also had designing and exploring new AR/HRI, which includes reimagining robot design and also immersive authoring and prototyping. And finally, we had novel interaction design enabled by AR/HRI, which included natural input interactions with AR/HRI and also blending the virtual and physical worlds together. That concludes our presentation. Again, we summarized by finding 7 new dimensions and also future opportunities and challenges. And again, we also have this website which summarizes all the papers that you guys can see and look into. Thank you again for listening to our talk. We hope this was helpful.